Let's have the continuation of kinematics in one dimension. So example number 5. The minimum distance required to stop a car moving at 35 miles per hour is 40 feet. What is the minimum stopping distance for the same car moving at 70 miles per hour, assuming the same rate of acceleration? Okay, so here is our solution. Okay, suppose the unknown acceleration is constant as a car moving at initial velocity of 35 miles per hour comes to a stop wherein Vf is 0, okay, and 40 feet. Okay, 40 feet is the change in distance. Okay, we find acceleration from this formula. Okay, Vf squared is equal to Vi squared plus 2a delta x. Okay, to get the acceleration, this is our working formula. Since Vf is 0, Vi is 35 miles per hour. Okay, and then 2 multiply with 40 feet. Now we have to agree with our units. Okay, since this is miles per hour, okay, we need to convert miles to feet. Okay, and from hours we're going to convert that to seconds. Okay, so we have acceleration is negative 32.9 feet per second squared. Now we consider a car moving at 70 miles per hour and stopping, okay, with an acceleration of negative 32.9 feet per second squared. From the same equation, its stopping distance is, okay, our final velocity is 0 and initial is 70 miles per hour. And then we're gonna convert everything. So since this is a feet and this is miles, we need to convert miles to feet. And from hours, we're gonna convert that to seconds so that we can have a cancellation of units. So therefore, our stopping distance is 160 feet. We assume that initial distance is 0 here. Okay, so our stopping distance is 160 feet. Okay, next we have free falling bodies. Okay, an object falling in air is subject to air resistance and therefore is not freely falling. Okay, so this is an example of free fall from rest. Okay, so from rest, therefore, our initial velocity is 0. But due to gravity, as you can see, okay, our velocity increases. So let's have example number 6. A baseball is hit so that it travels straight upwards. After being struck by the bat, a fan observes that it takes 3 seconds for the ball to reach its maximum height. Find the ball's initial velocity and the height it reaches. So here's our solution. Since the ball's motion is entirely vertical, we can use the equations for free fall to find the initial velocity. Okay, so let's have gravity as negative 9.80 meters per second for this one. Negative 9.80 meters per second squared, rather. Okay, so this is our working formula. So Vf is equal to Vi plus 80. Okay, and to solve for Vi, this is our working formula. Okay, so since Vf is 0, Vf is 0 because at the maximum height, our velocity is 0. So Vi is 29.4 meters per second. Now, find the maximum height. Okay, using this formula, why do we use delta y instead of delta x? Because we are talking about a vertical displacement. But we still have the same working formula. we only change x to y. So here's our working formula, and we're gonna get our change in vertical displacement as 44.1 meters. Okay, so as you see here, VF is still 0. Now, a ball is thrown directly downwards, okay, with an initial speed of 8 meters per second from a height of 30 meters. After what time interval does it strike the ground? Okay, so the equation for the height of the ball as a function of time is this one. Okay, wherein y final, that's the final height, is equal to initial height plus VIT minus 1/2 AT squared, and our acceleration is the gravity. Okay, so our final height is 0 because it strikes the ground. Okay, therefore, this is our working formula. Okay, negative 4.90 came from 1/2 of 9.80, so that's negative 4.90. Now, to solve for the time, you see it's in second power. Therefore, we're going to be using the quadratic formula here. Okay. Therefore, if we're going to get, or you're going to use quadratic formula, we're going to be solving two values for time, but the other one is negative. Therefore, we're going to neglect that one because there is no negative time. Okay. So our answer is 1.79 seconds. Okay, so here is another one. A stone thrown from the top of a building in here is given an initial velocity of 20 meters per second. So our initial velocity at point A is 20 meters per second. Straight upward. The stone is launched 50 meters above the ground. So this is 50 meters. Now, the stone just misses the edge of the roof on its way down, as shown in figure 2.14. Okay, so it actually fell on the ground here. Using initial time as 0, as that's the time the ball left the hand of this man. Okay. Determine the time at which the stone reaches its maximum height. So we're looking for the time it reaches point B. Letter B, find the maximum height of the stone. What is the maximum height from here to next? Letter C, determine the velocity of the stone when it returns to the height from which it was thrown. So we're going to be having what is the velocity at point C. Okay, now for A, our working formula, what are we looking for? Okay, the time to reach the maximum height. So our working formula is this one. Vf is equal to Vi plus 80, wherein Vf is 0, V has maximum height. Therefore, it will come to stop. Okay, our initial velocity is 20. Our acceleration is negative 9.80 meters per second. Therefore, we're going to have this working formula for time. Okay, therefore, our time is 2.04 seconds. That's the time to reach the maximum height. Now, what is the maximum height? Okay, so our maximum height is that is taken from the top of the roof. Okay, so top of the roof is our origin. Here is our point of origin. Okay, so our working formula is delta y is equal to VIT plus 1/2 AT squared. Okay, wherein YB is what we are looking for, assuming that YA is 0. But, okay, but if we assume that our origin is on the ground, therefore our initial height is 50. Okay, therefore you will have an initial value here as 50. Okay, it depends on your approach. Okay, now here it says our maximum height is 20.4, but that 20.4 meters is taken from point A. Okay, so from point A to point B, that's 20.4 meters. But if the problem is asking for the height from the ground, you're gonna be adding 50 more meters. Next, determine the velocity, okay, at point C. Okay, so we have this formula, Vf squared is equal to Vi squared plus 2a delta y. Okay, so since we're talking about the same height, therefore our delta y is 0. Okay, so we have our initial velocity as 20. Okay, then our gravity. So therefore our Vy, or the final, or the velocity at point C, is negative 20 meters per second. Why is it negative? Negative stands for the direction because it's going downwards. Okay, isn't it? From point A it goes upward. Okay, but at point B it comes to a stop, and at point C actually the velocity is going downwards. That's why it's negative. And that's all for kinematics in one dimension. Thank you.